Yes, sir. Yes, sir. And
Okay.
I called ma'am. Ma'am is busy right now with some PhD viva, so she will not be able to join.
Yeah,
So,
fine.
yeah. Good morning, everyone. I welcome you all in the fourth day of FDP, wherein in the first session we will be having Dr. K. N. Guru Prasad sir with us, and and the and today's topic is Introduction to Design Research Project. So before we start the session, it's my honor to introduce sir in front of you. Professor K.N. Dr. K.N. Guru Prasad is currently working as a director, Sri Vaishno Institute of Science, Sri Vaishno Vidyapit Vishwavidyalaya, Indore. He works in the area of plant science and specializes in photobiology and magnetobiology. He has an experience of teaching and research in life science of over 35 years. He was professor and head of life science department of Devi Ahilya Vishwavidyalaya, Indore. He has supervised the work of 25 research students who have worked under him for obtaining their PhD degree. He has been the principal investigator of various research projects funded by UGC, CSIR, DST, ICAR, BRNS, MPCST, and BASF India. He has worked as a visiting scientist in Kobe University, Japan, and Moscow University, Russia. He has over 85 research papers published in research journals of national and international repute. We welcome you, sir. Now I request sir for his deliberation. Sir, please.
Thank you, Madam Monica Saini, for your introduction. Uh, Madam Saini has been very generous in giving me a lot of time for this session, 2 hours. And uh, I see that there are about 24 participants right now.
Yes, sir.
And so I guess it is better to be a little interactive in the session rather than uh, just listening to me. Although, of course, I'll be taking the major part of that. And if the participants have to interact, how do they interact? Is it only through a chat box, Madam Saini?
Yes, sir. It's
It is
through
through the chat
chat box
box.
only, and if they want to ask something, we can allow them to ask from you directly.
Okay, but right now their audio uh, will not be enabled, right?
If you want, sir, we can do that also.
No, we can. I can use the chat box. Fine.
Yeah, yeah.
So the topic which has been given to me to speak to you, I understand that this series is being held in the light of the new education policy and how this policy is different from what we have been following till now in all the colleges and universities. And one of the important components of this policy is research, and both at undergraduate level and at postgraduate level. Because so far, when we talk about research, since most of you have done your PhD, we only think of PhD when we talk of research. Now, that concept needs to change in the new education policy. So before I open my slides, here is a question for you, uh, which you can send your answers in the chat box. Uh, I will take a minute to open my slides. So in that minute, you can send your reply. Now, what do you understand by research? Because you see, the research has the word search. There is a word which we commonly use, search, and then this is research. So you just let me know how do you differentiate between search and research in the next 1 minute. And in the meantime, I open my slides.
So they all are interested to listen to you only. Three participants has taken the permission uh, from Ludhiana, I guess, because of some rains and all. So internet is not working over there. So they said that they are going to join after half an hour. So
Okay,
slides are
that's fine.
visible.
That is
Yeah.
fine. That is fine. And uh, so slides are visible.
Right, so visible.
Okay, I put it on the slideshow. Is it
Yes,
visible now?
yes, yes, yes.
Okay. So this was the topic which I was supposed to speak on: introduction to design a research project. So I asked the question which I didn't get reply in the chat box. So I hope people are listening to me. And this um the difference between search and research is, see, we can search for anything. Sometimes we misplace a thing. It's very usual for us to misplace something, misplace a specs or misplace a pen or something like that, and then search for it and get it back. But what is the difference in searching like that, searching randomly for something and researching? Now, the difference is here. See, since I come from science, I usually quote from scientists. So, Albert St. George was one of the greatest biochemists. He defined this research is to see what everybody else has seen and to think what nobody else has thought. Now, that is the difference between just searching and researching. It's not just seeing for a missing thing, but to think differently when we find that. Then, say for example, we can take this very well-known example of Newton's theory of gravitational force. If you look to the story behind this, it is always related to the falling apple, uh, by which he discovered the theory of gravitational force. Apple was falling for a long time. Everybody had seen it, and nobody thought of a gravitational force because Newton observed that when the apple falls, it falls in a straight line. Now that made him think, why does it fall always in a straight line? So that led to the discovery of gravitational force and also the mass of the matter, because the mass of the matter determines how the matter is going to fall to the ground by gravitational force. Now, um, I was asking the difference between this search and research. So, search is you can just search for anything, try to find something by looking at this, or if you have misplaced or if you have lost something, you look for it. But research is different, since research means to investigate systematically into something. That is research. So when we do research, there has to be some purpose. Now, why do we want to investigate systematically into some subject? Because research can be done in all subjects. Since in this group, we have people from engineering, science, management, and literature also, and commerce, and various subjects. Madam Saini had sent me the list, and I just saw that it's a mixed group. So what I'll be speaking is something I hope it will be relevant to all the people participating in this. Although I will go a little more into science because that's the area where I work. Um, so the purpose of research is to find out what is known, because many times we know something, but still we don't know it, in the sense that we don't know the exact meaning of it. Now, and also in the course of research, we will also search for what is not known. And then we have one more purpose in research, that what we can develop further from the knowledge we gain by this. What are we going to develop further? So these are the three major purposes which are listed for doing research in general in any subject, not confined to any particular subject. Now, since there are many people of management, let's start with. I don't work in this subject management, but still, I was interested in finding out because by chance, when Madam Sani sent me the invitation, I was reading another article, and by chance, I found this question in that article that who coined the word management for the first time in uh, in our knowledge base? Who coined this word management for the first time? And also, another question is, what's the meaning of this word management? Again, if you can send something in to the chat box, I'll be happy while I'm speaking. Um, this uh, okay, so let me go further. That it was very interesting for me because when I came across a discussion in that article, who coined the word manager for the first time, then I was quite surprised to find that the first time the word was used in 1589 in by Shakespeare in one of his works, that is Love's Labour's Lost. See, Shakespeare is one of the most researched author in literature. In literature, people will know it, that no author has been researched as much as Shakespeare has been researched. And he coined many words. I think I have a few more words later in my slide. But management was the word used first time by Shakespeare in 1589. Then I was curious to know what this word means. The root word for this manager is the French word which is called as manage, which means horsemanship. That is the handling or training of a horse. This was the first root word for management, manager in French. There was a similar word in Italian called managio, which meant the same thing. So horsemanship. Of course, today's managers don't deal with horses, but this was the root word from which the manager word came. The Latin, this had an origin from Latin by using another word called mammus, which means hand. So manager means handling something, and it was first used for handling the horses. So that's why it was called as manage. But handling the affairs, later it assumed different meaning. Say, for example, in 1570, the control or direct by administrative ability was, this was handling the human resources in administration, and the manager meant this. And that is how Shakespeare used this for the first time. Then it has various meanings, like to wield a tool or object by hand. This was also the same word meant using a tool or an object by hand. And then it took a different meaning, like get by or carry on affairs, carry on affairs. And by 1732, it assumed more meaning, like effect by effort or succeed in accomplishing something. So all these meant managers. And now we know that we have a subject, management. So we have forgotten the horses. It has nothing to do with horses now, but we have developed a subject which can make people succeed in accomplishing many things or make people effective by their effort in dealing with anything, whether it is financial matters or whether it is human resources or whether it is production or whatever it is. So this is how a subject develops, and this is how the research continues. I was telling that Shakespeare has coined many other words. Like these are some of the words. This is for the sake of people in literature to know what are the other words Shakespeare coined. Very familiar words and phrases. Like critic was the first time this word was used by Shakespeare in Love's Labour's Lost again. Then jaded is another word which was used in Henry VI by Shakespeare. Then it's Greek to me is a phrase which was used in Julius Caesar in this book. Then that means if you don't know something, you always use this phrase, it's Greek to me. Then all that glitters is not gold is a very familiar phrase which was used by Shakespeare in Merchant of Venice. And then wild goose chase when you make a futile attempt in finding something. So that was used in Romeo and Juliet by Shakespeare. So Shakespeare used a lot of these words. I took these words because Shakespeare was not a manager, but still he used the word management for the first time in his literature. So you will find in literature when this word was used first. So these are some of the things I by chance came across when I got this invitation. So I thought I will include this because there are people in management in this group. I usually speak only to people working in science. It's very rare that I get a chance to speak to some others. Uh, Now, going further to research, uh, the teaching, see, we do both teaching and research in the universities. Teaching provides the knowledge about what others have researched. Because if you take a book or a reference papers to make your teaching notes, that means that is a research done by someone else, not by us. But if you do research, then the original research provides your own contribution to the knowledge. Now, what is your contribution to the knowledge? If you can write a book, then that is your contribution. Or if you can write a research paper, find something new, so that will be the contribution to the knowledge. Universities, see, this was the basic difference we had in this country between the college and the university. The colleges were meant to do more of teaching and less of research. And the universities were supposed to be the seat of knowledge where the knowledge was created by research. So research, even now, if you look to the uh, NAC assessment, uh, NAC assessment formats, NAC gives more importance to research when they are assessing universities and less importance to research when they are assessing the colleges. So they have made a difference in that assessment because the universities are supposed to be the seat of knowledge where research is supposed to be extensively done. Now, in the new education policy, of course, there is going to be a dichotomy. The new education policy is contemplating on differentiating between the degree awarding colleges, which will do teaching, more of teaching and less of research, and then research universities, where the research will be more in focus than teaching. So they are going to make it something like that. And then they are also contemplating to identify about 100 universities which are to be recognized as research universities. Now, what are the advantages of research? These are some of the advantages of research, irrespective of the subject in which you are working. That research helps you in developing the critical thinking expertise. You learn analytical skills in the process of research, the communication skills, I think those who have done research will agree with this, that we have learned all this. I've also done research, and those who have done research know that we have uh, got all these advantages by doing research. Then, besides the development of one's own personality, you also research is essential for the social and economic development. How research affects the social and economic development? I have chosen a science topic today to illustrate this to you, and you will know it. Then, uh, research is also essential for placing the knowledge, whatever we create during research, at the service of the development, or convert this knowledge to applications. Because this is particularly important in engineering and science, where we convert our scientific findings to technology. This is the difference between science and technology. When we convert the researchers in science to applications, then it becomes technology. So the roots of technology are always in the researches which are done in the basic sciences, and from there the technology develops. Now these are the advantages of research. But how do we, since Madam Saini has given me the topic of research design, now how do we design a research project, or how do we think of a research project? Uh, Let me take an example away from my uh, subject of science, like literature. Say, for example, in literature, there is one type of literature called fiction. I'm very much interested in this because uh, I keep reading, and sometimes, very, very rarely, I do write. But this fiction is further divided into many types, like it can be contemporary, or historical fiction, or scientific fiction, or it can be a fantasy fiction or mystery. There are many more categories. Like, for example, I have not included two very popular categories. Like fiction can be detective or detective fictions, or it can be, of course, the detective fictions come under the mystery. Sometimes it is included in mystery, or uh, fiction which are classified as romantic fictions. There's various other categories also of fiction, which fiction has too many categories, but these are some of the important ones which normally are found. Now, how does a person who wants to write a fiction designs his project? It's not purely out of imagination. For example, if someone wants to write an historical fiction, then he concentrating on some part of the history, has the knowledge of that history, and then runs his imagination to develop something more out of this. I give you one example of a book which I do not know whether many of you have seen this. People in English literature might be knowing about this book, very famous book that came in the 70s called Roots. This was written by Alex Haley. He was the author. Now, like like it says, the saga of an American family. Alex Haley was a uh, black American, and he tried to trace the history of his own family, which had already lived in America for about maybe 4 or 5 generations. He was the fourth or fifth generation person of this family. Then he tried to find the roots of his own family and traced it back to Africa, from where uh, he goes in this book. He goes back in time to about 7 generations, and traces the seventh generation to a small village in Africa. From there, where they were originally brought as slaves to America, and then they settled in America, and things changed. the social and political things changed, and Alex Haley is one of the popular authors in America, and his famous book Roots is this famous book. I had read it when I was doing my research. Of course, I was doing research in science, but had read this book very long back. Then, by chance, I came across some notes on my own family and started doing roots of my own family, and that became a fiction. So this is my roots, which is given in the form of the book, The Coffee Track. Uh, so you can think of research depending upon what you wish to do, in which area you wish to do. Though I don't work in literature, but this is just one book there. Now I come back to science. Um, See, in science we find problems which interests us since I work in biological science. But I've taken a subject which may be of interest to all of you because all of you know that all of you use refrigerators and air conditioners in your home, and you know that now the latest types of refrigerators and air conditioners which you get are called as CFC free air conditioner, CFC free refrigerator. CFC is the chlorofluorocarbon gas which was used as a refrigerant for a long time, and now we don't use it anymore. Now, why did we stop using the CFC? You might have also heard about something called ozone hole in the climate. Now, I tell you what is the connection between your refrigerator and the ozone hole, and how the scientific research brought a technological change in our everyday life. Now, this is how research progresses, and this is how we can find research problems. Uh, Now, this slide shows there are three types of UV radiations that come from the sun, which we distinguish as UVC, UVB, and UVA. Those who are not familiar with radiations need not bother about how do we distinguish this ultraviolet light. This but those who are in science know that this is based on the wavelength at which these radiations are transmitted. So UVA is 315 to 400 nanometer. This is 280 to 315 nanometers, and this is below 200 nanometers. It's called as UVC radiation. Now, these are most harmful radiations, and these radiations are absorbed in the atmosphere. Like, for example, this slide shows you this is the altitude, and this is the ground level where we are exposed to sunlight. And when we are exposed to sunlight, we are also exposed to these two types of UV radiation. One is the A, and another is the. This is a small part of B. Not we are not exposed to the whole of the UVB which is coming from the sun, and we are having zero exposure to UVC because this is most harmful radiation. We cannot survive if we are exposed to this. So this is absorbed. Now, how these two radiations, which are very harmful, but which are coming from the sun, are not allowed to reach the global surface. Now, this is done because of two gases which are present in our atmosphere. One is oxygen, you are very familiar with it, and ozone is another gas. Now, this is the ozone. Ozone is O3, oxygen is O2 in the chemical form. So one more atom of oxygen will make oxygen ozone. Now, this ozone, if you look to this graph shows the concentration of ozone. If we go, there is very little ozone here in the ground level, but if you go higher in the altitude, say 20 kilometers or about still further 30 kilometers, you see the maximum ozone is here in about 30 kilometers. It spreads up to 40 kilometers, but this is the ozone present in the present above the atmosphere. So this is called as a stratosphere. We call it a stratosphere in an atmosphere. So if you go 30 kilometers above ground level, then you find the maximum ozone. Now this ozone is extremely important because it absorbs the harmful radiation of UVB radiation. So it reduces the amount of UVB reaching the ground level. And uh, UVC is absorbed by the oxygen. Those who are interested in chemistry, I can just tell you this, that this is what is UVC, that is below 280 nanometer. So this is absorbed. This is what happens. These are the photochemical reactions that happen in the stratosphere. That means how the ozone is formed. So this is how the ozone is formed. The oxygen gets split to monooxygen, and then this combines with oxygen to form the ozone. And the ozone, once it is formed, it will absorb the UVB radiation and again breaks to oxygen. So we have a continuous formation of ozone from oxygen and oxygen from ozone. These are the photochemical reactions that take place, say, some 30 kilometers above the ground level. But this is the extremely important reaction because we can exist on this ground only because of these reactions, which are absorbing both the harmful radiation of UVC radiation and most of the UVB radiation. So that is how we are existing. Now, what happens to what we call as ozone hole? Some of you may be familiar with this. What we call as ozone hole is when we started using the refrigerators, uh, we used these gases, freon and freon, CFCl3, CF2Cl2. This is why it is called as CFC gases, because it has got these three elements: carbon, fluorine, and chlorine. Carbon, fluorine, and chlorine in various amounts. And when this gas leaks to the stratosphere, so then that also absorbs the UV radiation. And when it absorbs the UV radiation, it makes a chlorine ion. And this is destructive for ozone because this chlorine ion can destroy ozone, convert it into oxygen and chlorine monoxide. And it can further break down chlorine monoxide to chlorine dioxide. And again, chlorine dioxide can generate another chlorine radical. So this continuously depletes ozone. You see, you get oxygen on the right side, but ozone is getting depleted on the left side. Not only uh, CFCs can do it, but even the oxides of nitrogen. These are emitted from the automobile exhaust. They can also destroy ozone and convert it into oxygen. So all these deplete the ozone, and uh, but then if this was so harmful, why were we using this chemical? Uh, we were using this CFC gas in the refrigerators before because of the advantages. You see, this has no odor and it does not affect the food items, and it is non-combustible, safe for the kitchen. So you don't hear any fire accidents because of the refrigerators or air conditioners because they are not combustible and they are easily compressible. So these were the advantages of using the gas uh, in the refrigerator. So at the time the scientists found this advantage, they were not aware of the ozone depletion, that it may deplete ozone later. It can become harmful pollutant. They were not aware of that. See, this is how the research progresses. Now, when did we come to know that this gas is harmful? This we came to know by 1970s. You have heard about Antarctica expeditions. So the first research station is called as Holly Bay Research Station, established in Antarctica, and this was done by British Antarctica Survey, and they detected for the first time the loss of ozone. And later, when they measured ozone again in 1985, they found that this ozone loss is becoming more and more. That in Antarctica, almost 70% of the ozone was lost. That is just over the South Pole. And in cold countries, temperate countries like Canada and Siberia, the loss was about 25%. But in other regions, we come in the tropical regions, the loss is less. It's only about 10%. This is because of the various um, differences in the atmosphere between the equator and when we move towards the pole. I come to it later. Now, this is how the ozone hole was detected, and it was continuously being measured in South Pole. And you see that this green, about 300 to 340 units, this ozone mapping spectrometer is called as TOMS, that is Satellite Total Ozone Mapping Spectrometer. Now, here, this is called as Dobson units. Don't worry about these units, except to know that wherever you find this green color here, so that corresponds to about 300 to 340 Dobson units of ozone. And that is considered to be normal ozone required for our safe existence on this global surface. But when it is depleted because of the pollutants like CFC, this is what happens. Like as you move from the equator, as you move towards the pole, you see the ozone is decreasing. It is going to the blue side. So in 1980, it was on this blue side, blue region, which corresponds to about 220. That means 100 units were already destroyed. So 50% was already destroyed here in the South Pole. Not in all places, but only in the South Pole over Antarctica. Then later, when the same measurement was done in 1991, say after a gap of 10 years, then you see this ozone depletion became more because here 10 years back it was somewhere around 220, but it went to the pink region, which is about 100 to 140, this region. So this is what is called as ozone hole. Ozone hole doesn't mean you make a hole in the atmosphere, but it is thinning of the ozone. That it continuously started thinning. That it was, this is the safe zone, safe amount of ozone, but it became less and less in the Antarctica, and then continued to become less. So people were worried why this is happening, because if this was allowed to spread to all other regions, then it would have increased the UV radiation in the sunlight, and that would have had very detrimental effects, like it would reduce the uh, production of food because it will affect the plants and reduce the yield. And many, it also causes many diseases. I don't know whether I have a slide about the effects of this, but anyway, I will see. But what happened was, the once CFC was found to be responsible for this decrease in ozone and the harmful UV radiations coming to the surface of the earth. So it was decided not to use CFC. That is why, see, this is how. This is the basic science that leads to the change in technology. The change in technology was to use the refrigerators and air conditioner free of this CFC because this was harmful. So now we know that currently we, this is being cured. This is called the curing of the ozone in the South Pole. So we are slowly returning to the green zone here also. Now, you see, the CFC, when it was first used in the refrigerators, it was synthesized by the chemists in 1928 by these people, Thomas Magley and in General Motors. This was the first, General Motors, known for production of cars, was the first company to produce the refrigerator also. Then Crutzen in 1971 had found that oxides of nitrogen react with ozone. And in 74, the CFC was found by these two people, Roland and Mario Molina, and they made the theory in 1974 that these chlorofluorocarbons, which are used in the refrigerator, can possibly destroy the ozone in the possibly destroy ozone in stratosphere. So based on this, in order to prevent the destruction of ozone, there was an environmental law formed in 1989, which is called as Montreal Protocol. So in this Montreal Protocol, it was decided not to use the chlorofluorocarbons. You see, the importance of this work was so much. It was the importance of this work was not realized in 70s, but it was realized in 80s when the ozone hole was detected. And these people, all these three people, Roland, Mario, and Paul, were given the Nobel Prize in Chemistry in 1995. So this is how the for the formation and decomposition of ozone. So this prize, this is how the science makes the progress, depending on what type of research you do. And when you do the research, it may not be, you may not realize the importance of that research, because these chemists did not go to South Pole to measure the ozone level. That was done by British Atlantic Survey. So that was done by few other scientists. But the importance of this work was realized when the ozone hole was detected. So this is how research progresses in science. So this production was ceased in 1995, and this was replaced by another compound which is called as hydro uh, HCFC, because compared to CFC, this HCFC had less potential to destroy ozone. This had the potential of zero point 0.6 to 1.0, whereas this gas has zero point zero 0.01 to zero point 0.5. That means nowadays what the refrigerators which we use have this different gas. HFC, because this doesn't have chlorine, and although it reduces the um, destruction of ozone, this HFC has another problem because this is a potent greenhouse gas because it contributes to the global warming. And so in 2019, this is the latest, that there was an amendment to the Montreal Protocol then to reduce this gas also by 80% in the next 30 years. And so the research continues. I took this example to tell you how research continues from, it started in 1970 on CFC, on finding a gas. In 1928, the refrigerators were produced, but over the years, we are continuously changing the technology, and that is how the research is useful for social development if you do research in science and technology. Now, but the scientific research in India is not adequate. That is what most of the scientists believe. So the reason for decline of science in India is the lack of experimentation as part of learning science. This is what Jayant Narlika had this opinion. I hope you know the famous person, Jayant Narlika. Now, this applies to all subjects that over the years, the research component became lesser in our curriculum, and passing examinations and reproducing textbooks without applying critical thinking became a routine practice in our teaching, both in colleges and universities. So the new education policy tries to change this understanding. Now, how can we change this? One of the way to change this is to introduce undergraduate research. Undergraduate research is an inquiry or a research conducted by an undergraduate student who can make an original intellectual contribution to the discipline. So this was first formed in USA, which is called as Council of Undergraduate Research. So that means you need you need not limit research only to those people who will do undergraduate, who will do graduation and then post graduation and then come to research. That's not necessary for doing research. Research can be done, research can be introduced right at the undergraduate level, and so that the students are trained to have some original thinking and also develop the critical thinking to inquire into the problems even while studying. So you don't need a degree of graduation or post graduation to do research. Now this is the new concept that has to be introduced in the new education policy. Now, if you take the researchers per million, you see where India stands. Per million population, USA has 4,300 researchers. China has 1,200, and we have only 215 in the last data which I could get. Of course, in terms of investment, also USA invests 2.74 and 2.11 in China of GDP. Our investment is only 0.62. Of course, our GDP is also less. And this, if we, in the new education policy, if we have to do more research and also introduce research at undergraduate level, we need to increase both the things. That way, it is, we need, of course, more funds here, more funds to do that. And then once we have more funds, maybe it will be possible to increase this number, the number of researchers in all subjects, whether it is science, technology, or management, or commerce, or even in social sciences. Now, how do we measure a good research? The parameters which are generally used to measure a good research, because we always hear that, particularly in science and technology, the Indian research is not rated very high because of our because of these parameters which are used to measure how much research a country is doing, or how much research a university is doing. Often we hear that in the first top 200 universities, Indian universities do not come. Now that is because of less amount of research we are doing, less amount of research. Now, what are the parameters to measure a good research? These are some of the parameters which are taken for measuring what's a good research. That each journal, there are national journals and then there are international journals. So international journals usually have a higher impact factor, particularly in science. I tell you later how that impact factor is measured in our how this impact factor is measured in our systems. Then, so this is one of the factors in which journal you are publishing research, determines the quality of your research, whether it is in national journals or in international journals, and what's the impact factor of these journals. Then there is another parameter to measure the impact of your research, which is called the Citation Index, which gives you how many people are referring to your work. That if I think that I have done good research, and if I always think that I have published a very good book, that's not sufficient, because it doesn't depend on self-certification. It depends on how many people are referring to your work, and that is what index uh, citation index can tell you, that this how much is how many papers, how many of your papers are referred, and we can measure the citation. It is quantified these days. There are methods by which the softwares are available which quantify the data. And once you publish the papers, it will keep on sending you the data. Once you register, you can check your citation index, how many people are referring to the work which you have done in research. Then, of course, this is for science and technology, and that is patents. If we have made some innovation, and if we have found something new, some new gadget or some new process, then that can be patented. I was working in Japan for 1 year in Kobe University, doing research on the UV radiations, which I was talking about. And there was a professor of engineering in Tokyo Technology Institute. So Tokyo Technology Institute is like the IITs in India. It is one of the premier institutes, and every student, engineering student in Japan, he aspires to join the Tokyo Technological Institute to do his engineering because that's one of the premier institutes. Now, there was one professor there who had made a lot of innovations, and uh, after a few years, he left the Technological Institute and opened his own innovative laboratory, research laboratory, and he used to employ only those students who will fail in the Tokyo Technological Institute because after getting admission, in the Tokyo Technological Institute, not all of them would get the degree. Some of them would not get the degree. Some of them, although they are very bright students, very intelligent students, but some of them would not complete the degrees. So this professor in Japan always thought that the most innovative people are those in the institute who do not complete the degree. So he used to employ only those students who would not complete the degree to his research laboratory, and he has some 20 or 30 patents when I had lost read about him, and all these patents were discovered by he has made enormous money because of these patents, and he continues to do innovation. That doesn't mean that the students who are getting degrees are not bright. That doesn't mean that. But he had a belief that innovative minds sometimes who are very deep into research and innovation sometimes are not able to cope up regular uh, with the regular curriculums which we have and the uh, regular kind of examinations and evaluation methods which we have. So that is the reason he always used to employ the students who may not succeed in the regular courses in his research laboratory. I don't know. I again go back to the literature. Maybe the people who are familiar with literature might have heard about a writer called Ayn Rand. She has written few books, but her books are quite popular. One of the out of the two books which he has written, one is the Atlas Shrugged, which talks about research, and another book she has written is the Fountainhead. Now, if you have read Fountainhead, now this is about architecture, based on architecture and architects, and in that book, uh, you will find what I am talking about because she has taken two characters. It's a fiction book, but gives a lot of insight into education and architecture. And in that book, Fountainhead, if you have not read it, you can read these two books. It will give you a good idea about research, although they are fictions. Fountainhead by Ayn Rand and also The Atlas Shrugged by Ayn Rand. Now, so in that book, the characters, one of the characters is who is who is the most sought after architect is the one who who was not able to complete the course in the School of Architecture as a student. So that is how sometimes it works. Not all people, like we have agriculture science, for example, in our university. And many times when I take lectures for agriculture science students, I always tell them that to know agricultural science, it is not necessary to read books. It is not necessary to come to the university. because I always tell them that the person who has a lot of knowledge about agriculture is the farmer who has never gone to any university. And what we are trying to do is only to assist him in with our innovation and our research, finding new varieties, finding high yielding varieties or resistant varieties, doing that kind of research, so that he can use. But the application part of this knowledge is with him and not with us. So we have a course, for example, in BSc and MSc in agriculture science, and it is compulsory for our students to spend um, 6 months with in the course itself. It is there that they have to spend 6 months with the farmer. They have to go and work. They have to get registered in a KVK, that is uh, the Center for Agriculture, Government Centers for Agriculture, and the KVKs attach them to particular farmers, and they have to go and work in with that farmer for the whole season of the crop. Say, for example, right now some of our students are working like that uh, in the fields for the soybean. This is the Kharif has started now. The rains have come, so the sowing has started for soybean in this area, and so they will be going to the farmer's field and they will be learning from the farmers how to sow the seeds and the how to maintain the uh, field. Just a minute, I'll be talking to you. Just a minute. I'll be getting back to lecture. Yeah, I'm in a lecture. Um, so now this knowledge they will gain from the farmers. So they have to work with the farmer for the next 3 4 months until the soybean grows, then it flowers, and then it produces the seeds and parts, and then it is harvested. So they have to know the whole process of how to grow soybean in the farmer's field by working with the farmer. So that's the knowledge. That's the knowledge that is incorporated into all other things which we do in our university. But such things are available right now only in few professional courses like agriculture science, like architecture. Now in the engineering, we send the students to the industries for internship. But in the new education policy, now we have introduced skill development and vocational training also along with our teaching. So we are sending the students of other subjects also to various areas. Say, for example, if there is a student of journalism, that person has to do a project by working with some known journalists or some known newspapers or some known TV news channels or some things like that, where the actual work is done, getting exposed to where the actual work is done. Okay, now, so the other things are, of course, books. Now, this is how the impact factor is calculated for every paper. Say, for example, impact factor, this was calculated for one of the best journals in science like Nature in 2014. So what they take is how many publication, how many uh, numbers were done in 2013 and 2 years. So they add this, and also they add how many of these papers published were cited in these 2 years. For example, Nature published 860 articles in 2013 and 869 articles in 2012. So this is the total number of articles produced. And out of these articles produced, how many were referred by other scientists? So you see, it was referred 29,000 times in 2013 and 41,000 times in 2012. So if you take this, then if you do the calculation here, then it comes to about 41.45. That is the impact factor. 2014, the impact factor of this journal is rated as 41.45, depending on how many of the articles have been referred by others. Now, If you do the same calculation for one of the premier journals of science that is published from India, it is Current Science, for example, and Current Science, which is published from Indian Institute of Science, one of the most premier institute in India. Then if you calculate, see the Current Science published about 400 articles. Each year it publishes about 400 articles in various numbers. Every month you get a number of Current Science. Then out of the 800 articles of 2 years, how many articles were referred by others internationally? If you see that, then you see 360 and 360. So the impact factor here becomes 0.9. You see the difference here between the two journals. Why we go for higher impact factor is because in these journals publish the papers which are most referred papers, and that is why the impact factor becomes higher. So an impact factor of a journal is dependent on how many of the papers published in the journal are referred by others. So I just give you a small idea about how the impact factor differs from one journal to another. So in planning research, we need to do quality research that can be published in journals with a higher impact factor, because this is the way the impact factor is internationally calculated. Now, we go into the requirements for research, that what do we, before we can design a research project, what do we, or do some quality research, what are the basic requirements we need for doing that? The first thing, particularly in science and technology, of course, the research funds are required in every field, but they are required to a lesser amount in social sciences, in literature, and even in management. Maybe you don't require a lot of fund, but research funds are particularly important in science and technology because you use a lot of chemicals in the laboratories. You use a lot of different types of equipment in the laboratory. So you need funds for all this, and so that is one of the major requirements for research, particularly for scientific research which involve laboratories. Others require mostly the research funds for computers and journals. This is where the research fund is required. That means the library has to have a lot of funds to update the researchers in terms of latest journals in that particular area. Then, of course, you require the research students who become the human resource. So in the new education policy, the human resource now, even the undergraduate students and postgraduate students are included in this human resource. It is not just the research student, but you can give some smaller research topics and involve the undergraduate students also to do research. But if we have to provide an opportunity for them to do research or research projects, if they are working in engineering and science, then we also need to provide them with laboratories and all the inputs required for the laboratory, like chemicals and like biological materials if they are working in biological science, and instruments. So we need to increase the research fund and also the facilities of the laboratories, facilities of the computers for them, and also the journals in the library. So all these need to be enhanced in order to increase the human resource. If we have to evolve, if we have to involve rather the undergraduate and postgraduate students along with our research students. Then the next question comes: how much time do we have to do research? This question comes particularly for the for the teachers who are doing teaching and research simultaneously, and I come to that time again in my latest slide. Then we need some work ethics. If we need more, if we want to develop more human resource for research, allow undergraduate students also to work with their ideas in the laboratories, then there will be a lot of wear and tear. That means we need to work ethics where we should freely allow the students to do the experiments, to try out their ideas. Some of them will fail, some of them may succeed, but some of them may fail. But we should develop this work ethics by opening up our laboratories to the students so that they can come and freely conservative in the sense that they would think what will happen if the students come and break things, what will happen um, um, if they waste chemicals. There will be all these things happening once the students come with their innovative ideas and work in the laboratories. That's why we need to have not only enough research fund, but we should also have develop the work ethics, that is open-mindedness. Particularly teachers are required to have an open mind to allow students to do mistakes. I remember the quote, one of the quotes from our former president Abdul Kalam, who said that perfection comes from experience, and the experience comes by making mistakes. See, this is how we need to develop the research attitude in the students. We should not always be worried about the waste they may do, or worried about some accidents that can happen in the laboratories. No, we should make room for all these and give them a free hand to work with their ideas. So that work ethics is absolutely necessary for developing the research attitude. Then research funds, for this is particularly for the teachers who are in this program, that where to find the research funds. Now, there are various agencies that can fund research, uh, like UGC that funds all subjects, but unfortunately for the last 3-4 years, UGC has not opened up its research funding. Before 3 to 4 years, UGC was inviting projects in all areas to fund the projects. I hope UGC will resume it, but for the last 3-4 years, this funding source is not very productive. Now, for science and technology, we have various other funding agencies like CSCR, Council of Science, Scientific and Industrial Research, then DST, Department of Science and Technology, then we have DRDO, Defense Research and Development Organization, then DAE, Department of Atomic Energy, then BRNS, which is under DAE. This is the Board of Research in Nuclear Science. Then we have AICT, then we have NRDC, National Research Development Council. Then we have Tata Energy Research Institute, which happens to be another funding agency. Then we have MPCST, that is the state funding agency in Madhya Pradesh. We also have some state funding agencies in different states, but I only quoted the MPCST. Now, so these are the various research funding agencies where scientific and technological projects can be sent. From time to time, these agencies announce in their websites, they invite projects. Almost every year, they invite projects. Some of them invite it every 6 months. Like, for example, DST usually opens its site every 6 months. And then Once you submit this, in some of the agencies like BRNS, you can submit the project anytime during the year, but they usually review the projects twice in a year. So once in 6 months, they will review the projects. Once you send the project, it will be sent to the experts and it will be reviewed. And then if the project is approved by the review committee, then you may be called for a presentation before the funding is done. So these are sources for science and technology. Now there are certain special agencies that fund research only in biological sciences, like DBT, Department of Biotechnology, then ICMR, this is the Indian Council of Medical Research, or Indian Council of Agricultural Research. So these are some of the agencies which fund projects in specific areas. Then there are also specific agencies for social sciences. Some of you working in social sciences may be familiar with this, like Indian Council of Social Science Research, or Indian Council of Historical Research, or Political Research, and international bodies like UNICEF and UNESCO also fund research projects in colleges and universities. So the first requirement which I was talking about, like fund requirement, uh, you need to plan your research by thinking of a project that can be sent to one of these agencies, depending on in which area you are working, so that you get adequate fund. And once you have fund, you can do independent research. You see, we cannot always depend upon our institute, our parent institute, to fund our projects, because funds. So we need to explore the external funding of the research. But these are not the only agencies. There are many more agencies. Like some of the private industries also fund projects, particularly in science and technology. Although this private funding is very less in India compared to other countries, but nevertheless, you can get some of the fundings. I think even in management, I think some of the industries provide fund for doing research in management. Now, although I gave you the list of the funding agencies, and uh, I did not tell you about who are the competitors. See, these funding agencies, it is extremely difficult to get funding from these agencies. Right now, only about approximately 10% of the projects get approved. The total number of projects which these funding agencies receive, out of that, only about 10%, on it, on an average, only 10% of the projects are approved. Now, who are our competitors when we apply to these projects? You see, all the central government agencies, whether it is IITs or national institutes or ISOs or Institute of Science, or even CSIR laboratories, CSIR institutes, or national institutes like National Botanical Research Institute or CMAP or CDRI, CFTRI, NERI, all these are national institutes. They have their own funding exclusively committed to research. But here also, the scientists working in these places can apply to the same funding agencies. We are in the universities, but we need to compete with people who are working in all these areas. It is not that funding is available only for people working in universities. No, it is open funding. So we need, why I am telling this is to tell you that our project has to be extremely good to stand this competition, because our competitors are working in all the national institutes, particularly in science. And then comes the central universities, which have got their own funding, but still the scientists and others working in the central universities will also compete with us for the funding from the same agencies. Then comes the state universities, which also get You see, uh, I'm right now in a private university. Earlier, I used to work in a state university in DAVB in Indore. Now, we used to have a lot of research funding because every 5-year plan grant of the government, they used to give some funding to the state universities for the purpose of research. So we used to get some funding from the uh, 5-year plan grants besides our projects, which we used to get individually from the funding agencies. But these facilities are not available in private universities. Private universities, very few private universities have their own funding for research. So if you happen to be in a private university, then it is all the more necessary to get an external funding for research. Like in Vaishnav Vidyapit, we have now about, in science and technology, we have 5 research projects which are externally funded right now, and to the tune of about 1.25 crores. That is the funding for research which we have from outside. Now, this is possible. Everyone can uh, work on these lines to do research by submitting projects and uh, by submitting competitive projects so that it goes through the screening, and also it is selected in spite of the competition from the national institutes and central universities and state universities and all these universities. So it is possible to get. Then the work ethics, I was talking about the work ethics. So these uh, points are to be kept in mind while developing, if you want to promote research in the institute and if you want to promote your own research. These are the points to be kept in mind to develop that work ethics, the atmosphere for doing research. All of you know, those who have done research, that research is a slow process. It's not a fast kind of thing. It cannot go in a great pace. It is a slow process irrespective of the subject. And that's why it requires time, patience, and perseverance, all these for doing research. Then, since our facilities are limited because of our economics, I told you earlier how much other countries, how much GDP is spent on research and how much GDP is spent in India on research. So we cannot give a lot of funds to all the laboratories or all the institutes. So it becomes necessary to share the facilities whichever we have. Now, these funding bodies are also thinking to establish, they have already established certain national facilities, particularly for doing research in science and technology. Since the equipment is equipment which we need for doing research in science are becoming extremely expensive. Um, and it is not possible to buy the high-tech instruments. Every laboratory will not have sufficient funds to buy those high-tech instruments. So in order to facilitate research, the national institutes are opening up their facilities to other universities. Like, for example, for scientific research in Indore, particularly in physics, there is in physics and material science, we have a um, facility of UGC DAE CSR that is called as Center for Scientific Research, which is supported by UGC and DAE. That's a national facility which is housed in the campus of DABB, but it is open to all universities of the country. So they have a lot of high-tech facilities there, which one can uh, explore and one can use. Similarly, some of the facilities available in Center for Advanced RRCAT, Raja Ramanna Center for Advanced Technology, is available to others. Only thing is you need to um, have you need to approach them, and you need to develop the project with them, and these facilities are made available. Even in Bhopal, Madhya Pradesh Council of Science and Technology has a laboratory that is made available to others. So these are some of the facilities for scientific research. But for other areas, certainly library facilities and few other facilities may be available that can help your research. So, and you need to establish a working atmosphere, because you need to cooperate, share the facilities, and also give opportunities to the youngsters to work with their ideas. So that is required for establishing a working atmosphere for research. Then we need to, this is incorporated in the new education policy, that promoting the interest of persons with more capabilities to do research. That means in the new education policy, we need to identify the students who have more capabilities to do research. Now, how do we identify that? One of the criteria that has been introduced in new education policy is that the undergraduate course now is of two types. Till now, we had only 3-year courses. For example, BA, BSc, BA or BSc or BCom used to be 3-year course, and the student had to study all the at least 3 subjects, choose 3 subjects and study them. Now, there is a one more opportunity of 4-year BSc. They call it BSc with research, or BA with research, or BA honors, or BSc honors. Now, in this 4-year course, those students who can score uh, about say 7.5 CGPA or more, they can go to the 4th year of undergraduation, whether it is BSc or BA. And in this 4th year, they can choose a research topic and work on a project. And if they can successfully complete that project, they can straight away go to do PhD without doing a master's. That means you don't require a master's degree in the new education policy to do research. So right after undergraduation, one can go straight to the research. Now these rules and regulations are now being changed to facilitate the direct entry of graduate students to research after completing 4 years of research. But those who would like to do postgraduate degrees, they can do 1 year of postgraduate degree after 4 years, or even the 2-year postgraduate degree will continue for those who exit after 3 years. So if you do not like to do research, you can exit after 3 years and join a MSc or MA course of 2 years. So there will be 2 options now available to the undergraduate students. Those who can directly go to research, and those who can do post graduation before research. Now, this policy is intended to promote the interest of persons who have more capabilities to do research. But the teachers will have to play a proactive role in identifying the students who have this potential to do more research. So we need to develop now. It will take time to develop this skill to identify the students who have more potential to do research. Then, if we have to improve research, one of the qualities required, which has been identified by the experts, is sharing, listening, and being open-minded can improve one's own research. Most of the times, we are more interested in talking, like I'm talking all the time. We only want others to listen to us, but we don't listen to others. That is the usual tendency we have, but that doesn't help research. your research, your own research can improve, or the research of your own group can improve if we be open-minded and to listen to others also. Listen to others who have worked in other fields or related fields, because many new ideas emerge from there while listening to others. So, listening and being open minded becomes an important component in developing the research attitude um, in the students. So, apart from all other things, this is part of the work ethics that needs to be developed. In research, we do not see what has been done, but we only see what is yet to be done. That is why research is a continuous process. Madam Sani introduced me and she told you that some 25 students have completed research under me, but my research has not stopped. I have 3 students working with me in Vaishnav Institute of Science. So my research continues because this, I only look at what is yet to be done and not what I have already done. Those Each student who comes to my laboratory to do research brings a new problem, works on a new problem. And that problem is not new only for the student, but it's also new for me. So my learning never ends because I need to work with the student to understand how to solve that problem. If I already have the solution, then there is no need to do research. Why the student should do research if there is already a solution to that problem? A student comes to do research to my laboratory only because there is something that is yet to be done. Only then a student comes to do research. And that is how the research progresses. The only difference between a student and me, or student and a guide, the only difference is the guide will have the experience of having done research for a long time, whereas a student is new to research. And that's all the difference. Otherwise, the problem will be new to both of them, and both of them will be exploring uh, how to go about finding solution to that problem. Now, the research students can also get fellowships from these 3 sources. Net fellowships are available from CSIR, UGC, ICR, and DBT. All these agencies give net fellowships. If you now they are making it compulsory. I think even for doing PhD, they are making it compulsory to have one of these fellowships. Besides this, there are research projects which are given to the scientists and others, principal investigators, where the fellowships are made available. So research projects funding has both funding for consumables, chemicals, and then instruments, and also fellowships. So the funding comes for all these 3 areas, and one can employ students in the projects. That is how um, we have about 3 students in science now working in project fellowships, uh, which are funded by external agencies. Then we have institutional fellowships. Very few institutes introduce these fellowships for promoting research. Um, SVV is one of those institutes which has introduced this fellowship. We call this as teachers assistants. Now, this teachers assistants fellowship is given to uh, the students who can pursue their research for PhD, but they will also assist in teaching. So that is why it is called as teachers assistants fellowship. And but these practically these students are full-time researchers working in our institutes. So this is institutional fellowships. Many institutes will have to introduce this kind of fellowship to promote research and help the teachers to get some research students under them. particularly those teachers who have already done research and who are recognized guides. Sometimes they find it difficult to find external sources of funding. So in those cases, the institutions, all the institutions, because in this group there are many teachers from other institutes. So you can convey this to your respective institutes to create certain institutional fellowships to promote research so that you get students under you to work with you for research besides the external funding. So this will be extremely helpful, and we have done this in our Vaishnav Vidyapit Vishwavidyalaya. We have already done this, and there are some teachers who are from my own institute here, my own university in this group, so they can avail this by uh, submitting proposals to have research students under them. Now, the big question for research, particularly for teachers, is the time. How much time do we get for doing research? How to find time to do research? We have to remember that all of us get only 24 hours in a day. If someone is doing more research, it doesn't mean that he's having more than 24 hours. No, he's not having more than 24 hours. Everyone gets 24 hours only. The question is, how do you utilize this time? See, UGC has given this some criteria for conducting teaching, since all of you are working in the colleges and universities. So they have a criteria like professors, associate professors, and assistant professors will have about 12, 14, 16 hours per week. Now that is the general criteria which they have. But it differs from one university to another, depending upon how much teaching load is there. This is generally given for colleges where they have undergraduate and postgraduate, both undergraduate and postgraduate students. So all these, if you particularly if you include practicals also in science, because practicals take more hours, double the hours of lectures. If there is 1 credit of lecture takes 1 hour, the 1 credit in practical takes 2 hours. So that is how we calculate. So it takes more time to do practicals. Now all these included, it will take about 20 hours per week for a particular teacher. Now, how many working hours a teacher gets? Say, if you get about, if you take 7 hours per day and 5 working days, you get about 35 hours per week. Now, if you take away 30 in these 35 hours, all the time that goes to your lectures, practical tutorials, and all things, then you are left only with 15 hours per week. Then in these 15 hours, you have to prepare for your classes also. So if you have a lot of teaching to do, then say at least you require 5 hours per week. And you are also involved in administration, then exam work and other activities in the institute. So that if we even calculate it as 5 hours per week. So all this will take about 10 hours away from your 15 hours, which is available to you. And that leaves you only 5 hours per week for uh, research, which is very less. So you need to find more time if you are interested in doing research, along with your other responsibilities. If you are working in a college or a university, you will have all these responsibilities of taking lectures, depending on your position, 12, 14, or 16 hours a week. And then also, you will have the responsibilities in administration, exams, and other activities, student activities. So all these, doing all these and then finding time for research makes it difficult for finding time. But if you are to uh, develop an active research group, you need to find more time. You need to find uh, work beyond what the institute tells you to do. Now, research time, for example, in Japan, since I have taken the research time in the countries where I have worked, and I used to work for more hours. I used to do more research when I was outside India than when I am in India. So in Japan, it's about 14 hours a day. They work for researchers in Japan in the universities. They work from 8 a.m. to 10 p.m. They don't bother about any other thing. So they get about 70 hours per week. And in Russia, of course, they work a little less. It's a very cold country, so they don't stay till 10 p.m. They stay till 8 p.m. So usually 12 hours a day. Of course, I have taken these two countries only because I have worked here for a long time. Otherwise, even in other countries, they work a lot. But in India, in research institutes, which are totally dedicated to research with no teaching, then they work about 40 hours per week. Whereas in the universities, which have got only postgraduate teaching, like I was in DAVV, the State University, and we are teaching only for postgraduate students, MSc and PhD coursework, and for some time we had MPhil. So here I used to get about 30 hours per week for my research because I hardly used to take 10 hours uh, of or less than 10 hours of teaching per week. So this gives more. If you happen to be in a university with only postgraduate teaching, then you can get more time for research. But if you have both undergraduate and postgraduate, then your time will be reduced to about 10 hours, 10 hours per week. So these are the challenges for developing the research projects, challenges in general. That is creation of laboratory and infrastructure facilities, which needs external funding. Then to find the full-time researchers, so you need to have these external funded projects to give them fellowships, or you also have to uh, get the institutional fellowships introduced by your respective institute to support research. Then to do innovations in technology and develop patents. Now, some of the funding agencies are giving incubation centers, particularly in engineering and science, and that can help in developing the technology and also developing patents with innovation. Then we need the link up with industries because to find the problems that have application and that will be of economic use or social use, then we need this link up with the industries. So you need to identify the best way for the science and engineering people to do research is to identify the industries near to you, around you, and take up the local problems which they have and develop your research problems in relation to that. So that's easier said than done, but you can explore those areas. Then it is also important to retain the researchers within the institute because best of the researchers, once they do research, they get a lot of offers from outside the institute and they may leave the institute. So this is also another challenge which the institutes have to face, not only to develop good researchers, but also to include them and retain them within the institute. So there are many incentives that can be given to those teachers who are active in research and who also get opportunity to do research outside the country. Say, for example, state universities and central universities have this provision. Like I worked outside the country by taking uh, what is called a study leave in the state universities, and in some universities it is called sabbatical. So the sabbatical is the university provides you the opportunity to work outside the country for 3 months, 6 months, or even for 2 years, 1 year, or 2 years, and keeping your job intact and also keeping your salary intact. You can freely go and do research in some advanced research in some institute. Particularly, this is important in science because most of the countries, developed countries, have more advanced laboratories compared to us. So we get an opportunity to work in advanced laboratories by introducing this sabbatical in the institutes. So these are some of the things that can help research, and I guess I have run out of my slides now, and uh, I wish to um, complete my sharing of the slides and take up some of the chats if there is anything I can discuss, because I see some people have written something in the chat, and let me see what is in the chat.
Sir, we have Dr. Swati Dubey Mishra. I'll request her to ask questions. She has some queries. Dr. Swati Dubey Mishra, madam.
Ma'am, I have a question.
Yes, please.
Sir,
Yes, ma'am.
some journals having very high impact factor,
Yeah.
but they have not listed in UGC Cure or Web Scopus, etc. So how they calculate the impact factor, sir? You have given the formula, which is
So,
based on.
ma'am, see, this impact factor is not calculated by UGC. UGC does not calculate the impact factor.
Yes, sir.
Impact factor is calculated by the people who run the journal.
Yes, sir. Sir, you have given the example of Nature Journal.
Yes.
Sir, here my question is that some journal having very high impact factor. So
Yeah.
how they calculate their impact factor, because they have not listed in UGC Cure 1, Cure 2, or even in Web
You
Scopus
see,
also.
the formula which I gave is the general formula which is used
Yes, sir.
internationally.
Yes, sir. Yes,
That
sir.
means like nature, how does it calculate? The nature calculates by screening the papers published in all international journals. How many of them have been referred?
Okay, sir.
Okay. And
Yes,
then
sir.
they will augment that data, because such softwares are available, right? Like you get the citation index of your own paper, right?
Yes, sir. Yes, sir.
How do you get
So
that citation index? You automatically
Google
get it.
research.
Google's
No, sir. Google research and
Yeah.
Yes,
How the Google research, same thing. How the Google research is calculating your citation index?
uh,
Because it is counting all those papers in which your paper has been quoted, right?
yes, sir.
So by quoting that, similarly, the journal does the same thing for all the papers published in their own journal.
Okay, sir.
So if you do that, then you get the impact factor of the journal.
Okay, sir. Okay. Thank you, sir.
sir, I have one question here.
Yes, ma'am.
When we search for our citation index, there is one H index and I index also.
Yes, sir.
So, what is the basic difference between the two? Because
Yeah, you can get that difference. Let me tell you the difference between H index and I index is I index gives the 10 research papers which are most quoted, whereas H index, suppose you have 50 papers, 50 research papers, okay, then suppose 20 of your research papers have been quoted maximally, say 20 times it has been quoted, right? So where the maximum number in which your papers have been quoted matches with your number of publication, that is called as H index. So your H index can be 20. That means H index shows that out of your 40 papers, 20 papers have been quoted 20 or more times.
okay,
If your I index can be 50, I index can be 30. If you have 40 papers, I index can be 30, because 30 papers might have been quoted 10 times or more. So these are various types of calculations. So they have several types of calculations. You can get these details in the Google only. You will get the details. all their formulas, how to calculate H index, how to calculate I index, and they have some more index, I think, S index or something. They have various types of indexes. So you can get the details into Google only.
So, similarly, we have impact factor, we have GIFs, something like that. Global impact factor. So, what is the difference between the two, impact factor and global impact factor?
See, impact factor can be some of the journals, for example, some of the national journals limit the impact factor to the papers published within the country only,
Okay.
not outside the. They will not take whether your paper has been quoted outside the country or not. They will not take an international journal for that. Suppose your paper is published, for example, agriculture journals in India. They have a rating impact factor which is called as NASA impact factor. So that is only limited to agricultural journals published in India. So if you publish a paper in an agriculture journal in India, they will calculate how many times your paper has been referred by others in India who have published their papers also in national journal. So it is limited to the national survey. Whereas if you take the international like Scopus Index and other things, so now they will take international journals. They will not look to the national journal, they will look to the international journal, where your paper has been quoted internationally. So this H index, I index, these are for the international references.
Yeah, thank you so much, sir. Sir, we have one more question from Snehalata.
Yes.
Snehalata, madam, you can ask your question. Snehalata, madam, you can ask your question. Am I audible to you? Okay, I'll just read her question. Her question is, good afternoon, sir. Very wonderful session, sir. One
Audible,
question. Yes,
am I
please.
audible, ma'am?
Yes, audible. Please go ahead.
Okay, ma'am. Good afternoon, sir. A very wonderful session, sir. I have one question, sir. I think I have one doubt, sir. What are the common points we should keep in mind while writing research paper or project? As per the expert opinion, who can judge the any kinds of paper of management department or a mixed commerce department. So I have one doubt, sir. What are the common points we should keep in mind while writing research paper or project?
Okay, I got you.
Requirement
Yes.
either from science department or other department.
Yeah, I got your question. So while writing a project, these are two different things. Like while writing a project, you have to choose the problem in which you want to do a project, and that will depend on which subject you are working in. Which is your subject?
Sir, commerce.
Commerce. So what is the most relevant topic in commerce which is being investigated by all the contemporary people doing research in commerce? Now that should be your first interest, because you are most likely to get a project in the area which is contemporary area of research. So that you need to keep in mind while writing the project. Of course, I'm not very familiar with commerce, but since I work in science. But while writing a research paper, that depends on what kind of original research you have done and how much important is your result, how much impact your result can have. So that will and how much clarity is there in your data and in your interpretation. All these will matter in writing a good research paper. So writing a project and writing a research paper are little different. For writing a research project, it is extremely important to identify the contemporary area in which the research is required.
Yes. Okay, sir.
Sir,
Thank you, sir. Thank you so much.
we have Dr. Manish Joshi with us. He has some queries. Sir, please go ahead.
Okay. Good afternoon. Thank you, Dr. Monica, ma'am. I'm audible.
Yes, yes, you're audible, sir. Please go ahead.
Sir, my sincere regards to you. I'm basically from the area of management, and I have grown an interest on space research actually.
Okay.
Because of two reasons. Point number one is globally, government is putting a lot of money on this research. Point number one. Point number two, I have observed a couple of corporate organizations like McKinsey and Morgan Stanley. They are also putting a lot of money. And since they are into corporate, and I don't know why they are interested to have some space research, especially for the management students, they wanted to work out and how it can, the findings can be useful for corporate houses. So, sir, can you help me out, being since you are a science guru, and you can help me out and how I can also enter and help out in this?
Yes, you see, from whatever little I understand about space research, because one of my seniors was working in a space application center in Ahmedabad. That was run by ISRO, Indian Space Research Organization.
Right.
So on the application side, this space people have this remote sensing technology. They apply this remote sensing technology extensively for economic benefits.
Okay.
Like, for example, in biology, they are using the remote sensing technique to, they can say, through space and using the space cameras and using the satellites, they can monitor a large area. For example, if they monitor a large agriculture area, then they can, there are various methods by which they can forewarn the farmers and the ground level about diseases or about about pests and diseases in particular, which can affect their crops. So that is one of the areas where they work. Now another area is like for example, in the ocean, there are many people go, and fishery industry is one of the major industries where they catch fish from the ocean. Now these satellite images, they have developed now techniques to identify the areas which are best suited for fishing in the sea. So they transfer this data to the companies which are interested in this business of fish business. So some of these things are what I have heard from my friends who are working in space applications.
Very fine, very interesting, sir. That's fine.
It may be used for other resources also, but these two resources I'm very sure of because I knew people who were working in these areas.
Right. If I'm into a food processing business or maybe into food technology, and maybe I wanted to invest, wanted to know globally where the tomato is being cultivated or something like this, so I can plan my investments or I can plan my marketing strategy accordingly, sir.
Yes, and you can also go through the applications of space. You know, you can just refer to the activities of Space Application Center in Ahmedabad before you decide upon, you know, which are the areas, commercial areas in which they are working.
So
there may be more commercial areas in which they are working.
So, do I keep a hope, sir, that I may start working and I may get some fruitful results?
Sure, why not? Why not?
So maybe taking your more advice and blessing, sir.
Fine. You can be in touch with us, and when I meet those people again, because I am having a meeting with them sometime in September. So if I come across something more, I can. You can be in touch with our organizer from management, Madam Monica Signing. So I pass it on to her, and you can take that.
I'll be in touch with ma'am and request her, because this area is growing, and that's the reason I felt like asking you. And thank you very much for helping me out.
Yeah, it's good that you brought this point out, but we also have very active people in management who can think of this.
Thank you very much, sir. Thank you very much.
Thank you.
Good day.
Sir, very good afternoon. This is Simnalika. Am I audible?
Yes, go ahead.
So a lot of heavy and intellectual stuff was being discussed, and I think my questions are very lame, and whether I should ask or not. Uh,
Every question is fine. Please ask anything you want to ask.
so just wanted to ask whether, say, like I am from management background, so should I go for Scopus Index journals or ABDC, which is the better option for me? Number one, and number two is again a little bit personal question. Since you are from literature background, who is your favorite author and in fiction, and your favorite book, sir?
Oh, I think I already quoted. I will ask your. I will take your second question first. I think I already included some books in my slides. So one of my favorite authors is, of course, Ayn Rand, and particularly two of her books. If you are interested in fiction, please read them. One is Fountainhead, and another is Atlas Shrugged, both by Ayn Rand. Otherwise, I read many authors. Uh, Not only Alex Haley or Ayn Rand, whom I have talked about, but in general, I read many others also, like Woodhouse, like Somerset Maugham, like uh, even Robert Brown in the recent times. So I read many authors.
All the classics you have already answered, sir. And
Okay,
these are the
okay,
very
and then
nice
you
books.
were asking about journals. So as far
Yes,
as I understand, I'm not very sure of management journals. Madam Monica Saini may also make a comment on this, but I think Scopus Index journals are most
Right, sir.
preferred. What do you think, Madam?
So I feel that SCI journal is Springer Nature, then SCI, then we come for ABDC, then UGC listed. This
Okay,
is why
so
you're
yeah, so this is the order I think in which management journals are listed.
right.
okay. So thanks a lot for answering.
Any other questions from the participants? We have one more message. Thank you so much, sir, from Swati Dubey Mishra ma'am. I guess we do not have any message now, questions now. Sir, on behalf of Shri Vaishnav Vidyapith Vishwavidyalaya itself, in fact, on behalf of all the participants, I'm thankful to you for sparing your valuable time for us. And I hope we must have learned something related to the projects, and we are into the process of making some projects. And once again, sir, thank you so much. And
Thank you.
yeah,
Thank you very much. And thanks to everyone who listened to me. Thank you.
thank you so much.
Thank you, sir. Good afternoon.
We are having one more session, post lunch session, and it will be taken by Dr. Santosh Rangnekar, Professor, Department of Management Studies, IIT Roorkee. And session is on e-content development for MOOCs and online teaching. So I request everyone to please be on time. We will be starting the session sharp at 2 p.m. Thank you.